Ever wondered what happens when you open up a file or load up a website? In this video, we'll dive into the fascinating world of computer memory, explaining how data is stored and retrieved in today's advanced machines. So let's get started. There are two main types of computer memory: volatile and non-volatile. Volatile memory, like DRAM or SRAM, loses its contents when the power supply is interrupted. Conversely, non-volatile memory such as SSD and HDD retains data even when the power supply is turned off. However, both types of memory play crucial roles in your computer's operation. We'll explore each one in detail later in the video. First, let's talk about registers. These are tiny storage areas located within the CPU that hold current instructions being executed by the processor.
Now registers
Are extremely fast with access times measured in clock cycles, but they also come with limitations. Since they're physically integrated onto the processor die, there's a finite number of them, and their capacity is relatively small. Nevertheless, registers are essential for enabling the CPU to perform calculations and operations at lightning speeds. Next, we have caches, which are high-speed memories that store copies of data from RAM or storage devices. There are three primary levels of cache: L1, L2, and L3. With L1 cache being the fastest, but also the smallest and most expensive. Each level is designed to hold frequently accessed data or instructions with higher levels, providing larger capacities at the expense of speed. Caches help reduce latency by providing quick access to information that the CPU needs immediately. Now, let's discuss RAM, which is a type of volatile memory that's used for storing active programs and files. Unlike cache, RAM is much larger and can accommodate more data. It also provides a random access, meaning any location can be accessed directly without having to start at the beginning of the memory space. RAM is significantly faster than storage devices like hard drives, making it ideal for managing actively used files. Finally, we have storage devices such as solid-state drives and hard disk drives, which are used for long-term data retention. SSDs have gained popularity due to their speed, reliability, and durability. They use NAND flash memory, which consists of floating gate transistors to trap electrons, representing either a 0 or a 1. These transistors enable SSDs to store data without any mechanical movement, resulting in faster performance and increased reliability. On the other hand, hard disk drives store data magnetically on spinning platters. They're slower and more prone to failure compared to SSDs, but remain an affordable option for large capacity storage. It's important to note that all these memory types play a crucial role in your computer's functionality. Now that we've covered the different types of computer memory, let's take a closer look at how data moves through the system. When the CPU requests data, it first checks the cache memory. If the data isn't found in the cache, it's fetched from RAM. This process is known as a memory access cycle. The cache stores frequently used data, allowing for quicker access than RAM. However, if the cache doesn't contain the necessary data, the CPU will request it from RAM. RAM in turn retrieves the data from the storage device. Once the data is available in RAM, it can be accessed by the CPU as needed. To ensure efficient data transfer, multiple memory modules are often used in parallel, enabling the CPU to retrieve multiple pieces of data simultaneously. In addition, techniques such as memory pipelining allow multiple requests to be processed concurrently, further enhancing performance. To illustrate the hierarchy of memory types, consider the following example. Let's say you're playing a video game. The game's textures and other assets are stored on the storage device, such as an SSD. When the game is running, some of these assets are loaded into RAM to allow for quick access during gameplay. As you interact with the game, certain assets may become more frequently used and are copied from RAM to the CPU cache. The cache provides even faster access to the data, reducing the time it takes to render the game. Now that we understand the flow of data within the computer, let's talk about how more RAM can lead to faster performance. Having sufficient RAM ensures that your computer doesn't have to rely on swapping to achieve better performance. Swapping involves using the SSD as a temporary space to store inactive programs or files, effectively swapping them out of RAM. This slows down your system as it needs to read and write data from the SSD, which is significantly slower than RAM. Swapping can cause noticeable delays in program loading times and overall system responsiveness, degrading the user experience. On the other hand, having enough RAM allows your computer to hold all the necessary programs and files in memory, eliminating the need for swapping. This means that your system will operate more efficiently with faster load times and smoother performance. Additionally, having ample RAM enables your computer to handle multitasking efficiently. When you open multiple programs or browser tabs, each one consumes a portion of your system's RAM. If you don't have enough RAM, your computer may start swapping, leading to decreased performance. However, with sufficient RAM, your computer can load all the required assets for each task into memory, ensuring smooth and efficient multitasking. For gamers, having enough RAM is crucial for an enjoyable gaming experience. Many modern games require at least 16 gigabytes of RAM to run smoothly, while heavy games or simulations may demand even more. With the right amount of RAM, games can load quickly, run smoothly, and provide an immersive gaming experience. Similarly, video editors and other professionals who work with large files benefit greatly from having ample RAM. Editing multiple layers of high-resolution video, for instance, requires substantial RAM to handle the large data sets involved. Sufficient RAM ensures faster loading times, smoother playback, and efficient processing of large media files. Let's talk about the future of memory. As technology advances, new memory types and technologies continue to emerge. One example is GDDR6X, which is currently used in high-end graphics cards. This memory operates at extremely high speeds, reaching up to 1 terabyte per second of bandwidth, making it ideal for graphically intensive applications. Another exciting development is Intel's Optane, also known as 3D XPoint. This technology bridges the gap between SSD and RAM by providing faster speeds than traditional SSDs, while offering non-volatility like RAM. Additionally, RMHM, or magnetic RAM, is gaining attention for combining the speed of RAM with the non-volatility of flash memory. RMHM uses magnetic tunnel junctions to store data, allowing for faster read and write speeds compared to conventional RAM. In conclusion, computer memory plays a vital role in determining your computer's performance and efficiency. Understanding the different types of memory, including registers, cache, RAM, and storage, as well as how they work together, can help you make informed decisions when purchasing or upgrading your computer. Whether you're a gamer, video editor, or just a casual user, investing in a system with adequate RAM can significantly improve your computing experience. As memory technology continues to evolve, we can expect even faster speeds and greater capacities, leading to better overall system performance. If you enjoyed this video and want to learn more about computer hardware, be sure to subscribe. Thanks for watching, and see you in the next one.